So this is going to be part 2 for the elimination method. Make sure that you've already watched part 1 before you watch this video. So this is chapter 6-4. We're going to be using multiplication in the elimination method. So let's take a look at our first example here, example 1. We want to use elimination to solve the systems of equations. We have 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. If you look at these two equations, they look different from the other ones we've already solved before. The first thing that you'll notice is that there is no matching coefficients. That means that for the numbers that are in front of the x's, they do not match. We have a 5 and we have a 2. And then for the numbers that are in front of the y's, we also have a 6 and a 3. So unlike the previous problems we've solved, the coefficients are different for both of the equations. So we need to do something a little bit differently in order to solve. This is the first thing that I wrote down. If the x or y variables don't have the same coefficients, then we want to use multiplication to change the coefficient. Let me show you what I mean by that. Over here, I've rewritten the two equations, and if you look closely, there is something that we can change about the second equation in order for the coefficient to match the first equation. I know that if I multiply 3 times 2, that will leave me with 6y, and then the 6 and the 6 will be matching. I can't multiply anything times 2 to get it to match 5. So for this equation, there's only one thing that I can do, and that is to multiply my equation times 2. Because like I said, if I multiply 2 times the 3y, I will then have matching coefficients. Over here, I wrote down what I just said. We can multiply the second equation to get the y variables to match. So let's distribute the 2 and multiply that times everything. When you do multiplication, you need to make sure that you multiply it times everything in the equation. Otherwise, you will be changing what it says. So multiply 2 times 2, that's 4x. 2 times 3, which is positive 6y. And 2 times negative 5, which is negative 10. Now I'm going to use the same top equation. I'm not going to change anything with that one, so I'm just going to rewrite it on top. So now I have two equations that have matching coefficients. I have a 6y and a 6y. From here, I can proceed and solve like normal. Again, if you didn't watch part 1, this part is very similar to the process that we've already done before. I'm going to subtract the equations because remember, when you have this same sign, a positive and a positive, you want to subtract because subtracting these will give you 0. So we're going to subtract 5 minus 4, which is just 1x, and then the 6's, 6 minus 6 will cancel out, so I'm going to cross them out, and then negative 8 minus negative 10. Again, be very, very careful when you are subtracting negatives. I'm going to write it over here. Negative 8 minus negative 10. Either use a calculator to help you with this part, or remember that if you are subtracting a negative, you got 2 minus signs, you need to change that to a plus sign. So negative 8 minus negative 10 is the same thing as negative 8 plus 10, meaning we have x equals 2. This is our first variable so far. So we've just solved for x. No need to do anything else because x is already by itself. Next, the second step, again, to solve for the other variable, pick one of your original equations and plug in your x value. Again, I said original equations, so if we look back up here, choose one of these to plug in. I'll just choose the top equation. I always just end up choosing the first equation. So I'm going to write it out, 5x plus 6y equals negative 8, and I'm going to plug in 2 for x. So plugging that in, now you just need to follow order of operations and solve. So first thing that I did was multiply. Next, I can subtract 10 on both sides, leaving me with 6y equals negative 18. Divide by 6 on both sides. leaving me with y equals -3. Again, when you are totally done with solving for both your x variable and the y variable, make sure to write your solution as x comma y, or 2 comma -3. And this will be our final answer. So to recap how we got here, the first thing that we do is we recognize that neither of these had matching coefficients. So we had to multiply the entire second equation times 2. Once I've multiplied every single thing times 2, I rewrite my new equation. Down here is the rewritten equation. I'm going to zoom in a little bit. The top equation didn't change at all. Next, we had to subtract them because we have positive 6y and another positive 6y. So subtracting them will get rid of the y's. We solve that x equals 2. Next, we just plug 2 back into one of the original equations, solve for y, and that leaves us with y equals -3. Again, if you want to see how to solve exactly for the variables again, I recommend you rewatch part 1. Alright, it's time to now take a look at some practice problems. Here's the first one. 9r plus q equals 13. 3r plus 2q equals -4. For extra practice, pause right now, take a look at both equations, and try to figure out if we can multiply a number, either multiply the first equation or the second equation by a number in order to get both of the coefficients to match. Okay, hopefully you've paused and tried to think of a number that will work. There are actually multiple ways that we could multiply something and get the coefficients to match. I will show you a few different possibilities. The first possibility is we could multiply the top equation times 2. If we multiply the top equation times 2, you will have these coefficients to match. So that means you would have a 2 times 9r plus q equals 13. And if you distributed that, you would have 18r plus 2q equals 26, and then the bottom equation would be 3r plus 2q equals -4. Right here, you now have matching coefficients. Another way that you could get your equations to match is to multiply the bottom equation. If you multiply the bottom equation, this second one right here, and you multiplied it times 3, you would also get something that matches. If you distribute this, you will have 9r plus 6q equals -12. And then copying down the top equation here, we had 9r, q, and 13. And now we would have these coefficients match. So there's actually 2 different ways that you could have done it. Both of these would work, and then from here, you would subtract the equation and solve. This one, you would also subtract the equation because both of these are positive. Now pause the video, try to solve both r and q on your own, and then answer the multiple choice question. So I've already gone ahead and solved both of these equations. Over here, I subtracted them and I solved for r. We got r equals 2. And for the second version, if you did it this way, you should have solved for q, and we've gotten q equals -5. Again, after you do either one of these methods, you would plug it in and solve for the other variable. But our 2 answers are that r equals 2 and q equals -. Okay, it's time for one last problem. We have 2x minus y equals 4, and 7x plus 3y equals 27. Go ahead and try to solve this problem on your own, and then we will review it. So for this problem, there's only really one thing that we can do, and that is to multiply the top equation times 3. If we multiply this times 3, this will make the coefficient in front of the y variable 3, and it will match the one below. So I'm first going to distribute this and multiply everything times 3. This will leave us with 6x minus 3y equals 12, and 7x plus 3y equals 27. So for this one, it's a little bit different. Remember, if you see an equation where you have a negative and a positive coefficient, these two have different signs, you need to remember to add together the equations. Because negative 3 plus 3 is going to be 0. So we're going to add in this case. Adding will cancel these out. 6 plus 7 is going to equal 13x. 12 plus 27 is going to equal 39. And then we're going to divide by 13 on both sides, leaving us with x equals 3. Now I just want to solve for y. So to solve for y, choose one of the original equations. I'm just going to choose the first one. So remember, use the original equation. You don't need to use the one where you've already distributed the 3. So we're going to use 2x minus y equals 4. Plug in 3 for x and solve. 2 times 3 is 6. We're going to subtract 6 on both sides. Make sure that you keep that minus sign in front of the y the whole time, because at the end we need to divide by negative 1 to get y by itself. So we got y equals 2 and x equals 3. Our solution, written as a coordinate point, will be 3, 2. Again, if you want more practice on this, you can always go back, rewind the video, and try the problems again on your own. If you made a mistake at any point in this solving process, you should try the problem again, try to avoid looking at the answers, and then make sure that you are able to solve correctly the second time.